Today we're going to be looking at domain and range. It's an idea that goes along with functions and relations, to be honest. It doesn't have to be a function to talk about domain and range. Domain and range refer to where does your graph show up. Okay, if you're looking out the window, what could you see? What would show up there? Okay, so when we're talking about domain, we want to know which x values are involved in this graph. Okay, what is the set of x's that we cover? And range, what is the set of y values that we cover? Okay. So we're going to look at this in a variety of ways. We're going to look at mapping diagrams, we're going to look at points, we're going to look at dots, we're going to look at lines. And each of them has a slightly different approach. Okay, when it comes to a mapping diagram, okay, as far as we know, these are x's and these are y's, but these are the only x's and y's that make up this graph. There's no more than what this diagram is made up of. So my domain, okay, we say x belongs to, and we use these fancy ellipsis brackets. Okay. X belongs to, well, the only ones we have are -3, -1, 1, 3, and 5. We make a list. Okay, that's the only x's that we know for sure are in this graph. When it comes to our range, we can do the same things. It's going to be y this time. Which ones do we know for sure in this graph? Well, -2, 0, 2, and 10. Okay, we have mapping diagrams, we make a list. If you can, put the list in smallest to largest to make your life a little bit easier, but that's not absolutely necessary. Okay, our second one, we got some points to make up this graph, some ordered pairs. So again, as far as we know, this is the set of everything that can possibly exist. So we got to make a list again. So our domain, x belongs to, oops, sorry, fancy bracket. Okay, and then we put our x's in here. Now, if you can, as I said, try and put them smallest to largest. So the smallest x I see is -2, then -1, then 0, then 2, then 4. And I suppose if you had a whole bunch of points, it might be a little hard to go small to largest. That's why I said it doesn't really make a difference. Just makes your life a little bit easier at times. Okay, our range, y. Y belongs to. What do we got? What's the smallest y that I see is a 2. In fact, I see 2 2's. Okay, there's one here, there's one here. But we don't have to list them twice. The fact that we've said there's a 2 involved in this graph is enough. That's all we need to say. There's a 2 somewhere in here. And there's also a 3 somewhere in here. Yes, there's 2 of them, one there, one here. But again, we don't have to list it twice. And there's a 5. Okay, notice that our domain and our range have different amount of numbers in each one. That's okay. There's 5 x's involved, but there's only 3 y's involved. And in fact, that can happen all kinds of places, especially when you start talking about functions versus relations, right? And if you don't have, you could have multiple y's for a single x's, things like that. Okay. If we don't have lists, but we actually have graphs, we have to stop and think about our graph. Is our graph made up of points, or is it made up of lines? If it's made up of points, like integers or decimals or things like that, we can list these. In fact, we have to list them. If it's made up of lines, we'll have to do something different. So I look at this first graph and I say to myself, hey, these are points. What points have I included? Well, the x's from left to right, so I start over here. My smallest x would be at -3. Right, this point right here is -3 and something. And then I have this one here is a -2. And then this one here is a -1. And so on. I got a 0, and a 1, and a 2, and a 3. And that's the furthest to the right it goes. So when we do our domain here, I can say, oh, my graph is between -3 and +3. That's sort of what I'm saying here. It's only integers. My range, my y. Okay, from the bottom up, what's the smallest one I include from here upwards? Well, the lowest one is -2. I got one at -1. That would be this one again. That's their y value there, right? I have one at 0. I have one at 1. Actually, I have 2 at 1. Right? I have one here. I have one here. I have 3, 1, and 0, 1. But I don't have to list it twice. I just say there's a number 1 involved somewhere. And then I got one at 2. I don't have anything at 3, but I have one at 4. So again, I'm saying all my graph is between a low of -2 and a high of 4. So if you stop and think, right here, I've sort of got like, I don't know, call it a window, if you will. of my graph is in that box. Everything that's involved in this graph is inside that box, specifically at these numbers. That's what we do with points. When it comes to lines, there is no way we can possibly list every single dot. For example, even if I just went and had a low graph, went from 0 to 1, and I said, okay, I want to include everything in between 0 and 1. Could you make a list of that? Well, you could say 0, then 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. What about all the things between that, though? Think of all the things between 0 and 0.1, right? You keep adding more decimals. That's smaller. That's between, sorry. That's between. That's between. And so on and so on and so on and so on. So we can't possibly list this. This is impossible. So we need another way of approaching these things. So what we do is we use something called set notation. That looks like this stuff here. Okay, and the way this is going to work, we'll do the first one together here so you can get an idea of how this works in case you forget from last year, is we say, okay, x is made up of real numbers. And by that I mean every single possible thing you can think of. Every integer, so that'll be the whole numbers, 0 and 1, all the decimals, 0.1, 0.01, 0.001, and even all the weird things between decimals. Okay, everything you could possibly think of. So we start off by saying because this is made up of, it's a line. Okay, specifically, so we use this big thick line here to say, okay, here's the ones I want to include specifically. And then we look at our graph. We start by saying how far to the left does this graph go, just like we did when we listed points. That distance there is -4, I believe, right? This point here is -4 and something. And then I say, how far to the right do I go? And I go all the way over to here. And this point is +4 and something. So we say, like we did with periodic functions, my x values are between -4 and +4. Okay? This one here says x is greater than -4, so it's at least -4 or more. This one here says x is smaller than +4. It never gets bigger than that value. And if we write them together, we say x is between -4 and +4. Okay, so just be careful when you're working your graph. This is your leftmost point. This is your rightmost point. Okay, we can do the same thing for range, except we're talking about y's this time. So my range, is it made up of lines? For sure it is. I need that y-e-r thing. How low does this graph go? The lowest point I see in this graph is right here at -1. Okay, that's my low, -1, up to y. So y's got to be at least -1. It goes up as high as this point right here, which we say is 1, 2, 3, 4, 4 and 4. So it goes up to +4. That's the highest it goes. Okay, and then again, I've got myself a little square at the window. I can say, oh, my whole graph exists between here and here, left and right, up and down, and it's made up of a line. Okay, can you guys try the second one? Pause it if you need to. See what happens. I got a line. So, all real numbers. How far to the left does this go? Well, this arrow says it keeps going and going and going and going. So there is no lowest value. How far to the right does this go? Same idea, right? Arrow says it keeps going and going and going. The last one, we had dots. They stopped right there. -4 and 4 and +4 and -1. But ours keeps going this time. So in saying it's between values, we could actually just stop and say, hey, you know what? This is made up of every single possible number you can think of, left and right, forever and ever and ever and ever. Okay, how about our range? Our range. Okay, it's still made up of lines. Specifically, how low does this go? Well, if we look at those arrows, they're going to keep going, 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 going forever and ever and ever. It goes down forever and ever and ever, right? So it never hits the bottom. So I don't have a bottom, but I do have a top this time. My top, right along here, what's that point? That's 0 and 3. So I never go higher than, on the y's, 3, right? So how do I show that? Well, I say y has to be less than or equal to 3. I never go lower than that. This is my highest point I ever reach. Okay, I only have half of an inequality this time. There's no lowest. Okay, that doesn't happen in this case because our graph keeps going down and down forever and ever and ever. Okay, that's the front side. So you guys flip it over, try the ones on the back, and see what you can do with those.